Hello, welcome back to 2H TV. If you've not subscribed to the channel, please subscribe for more educating content. In today's tutorial, we are going to look at acid, bases, and salts. Okay, so this is our topic for discussion. But for the purpose of this lesson, we are going to look at the various definition of acids and bases. Okay, and these definitions were brought were proposed or brought by three prominent scientists. And these prominent scientists, we have Arrhenius. Okay, so we have Arrhenius definition of acids. We have Bronsted-Lowry. Bronsted-Lowry are actually two different scientists that came together to propose the theory. And we have Lewis. Okay, so these are the three prominent scientists that defined acid and bases in their own ways. Okay, now let's look at the definition. Okay, so the first one should be Arrhenius. Now Arrhenius defined acid and bases based on whether they will be able to produce hydrogen ion or hydrosomium ion. So either hydrogen or hydrosomium ion, or if a base is dissolved in water, it's able to produce OH minus. Okay, so Arrhenius definition is based on the fact that if any substance being dissolved in water and it's able to produce either hydrogen ion or hydrosomium ion, then we term such substance as acid. Okay, so his definition in simple terms state that an acid is any substance or any compound at all which when dissolved in water produces hydrogen ion or hydrosomium ion. Okay, so therefore if we should dissolve HCl, okay, in water, so aqueous, now the bond will break and it will produce hydrogen ion plus Cl minus. Okay, because this substance when dissolved in water is able to produce hydrogen ion, Arrhenius says that this substance is an acid, so therefore HCl is an acid. Okay, now his definition for base, he stated that a base is any substance at all which when you dissolve in water it should be able to produce OH minus hydrosomium ion. Okay, so if we dissolve for example, we dissolve HCl in water and we produce H plus ion, so it means that this particular substance is not a base. But if we should dissolve maybe sodium hydroxide in water, okay, now the bond will break, right, and we will have sodium ions and what, OH minus hydrosomium ion. Now because this particular substance has been able to produce hydrosomium ion when being dissolved in water, it is termed a base according to Arrhenius definition. So basically this is the concept behind Arrhenius definition of acid. He based his definition of both the acid and bases on the concept that if the substance is able to produce hydrogen or hydrosomium ion when dissolved in water, that substance become an acid. So with his definition of acid, any substance at all that when you dissolve it in water it's not able to produce hydrogen ion or hydrosomium ion for the acidic part, or hydroxide ion, that substance can't be acid or either bases. Okay, so that is the concept of Arrhenius definition of acid and bases. Okay, now then Arrhenius definition of acid and bases became limited because Bronsted and Lowry realized that it's not all substances. They realized that there are some substances that also have acidic and basic characteristics. Okay, they have acidic and basic characteristics, even though they don't, like, they are not dissolved in water to produce hydrogen ion or hydrosomium ion or either hydroxide ion. Okay, so they realize that there are some substances that have acidic and basic properties, but they do not produce either H plus ion or OH minus ion when dissolved in water. So this brought to the limitation of what? Arrhenius acid. It was only limited to the concept of a substance being dissolved in water and being able to produce H plus ion or OH minus ion. So Bronsted and Lowry brought up their definition, and Bronsted and Lowry definition was based on proton transfer reaction. Bronsted and Lowry based their definition of acid and bases on the concept of proton transfer reaction. Okay, so we are trying to understand the various definitions. Okay, so after we've been able to understand the various definitions by these three prominent scientists, then we will use the definition to fish out the various examples that falls under them. Okay, now Bronsted Lowry acid, so their acid definition, they state that acid is simply any substance that is able to what? Donate proton. So in simple terms or basic definition, they said that acid is a proton donor. Okay, in simple terms, acid is a proton donor. That's the definition of acid with regards to Bronsted Lowry. And their basic definition for bases, a base is a proton acceptor. Okay, so try to understand the various definitions. Okay, once you understand the various definition, then we will be able to use the understanding from the various definition to what? Fish out compounds that are in align with Arrhenius definition, those that are aligned with Bronsted Lowry, and those that are aligned with Lewis. Okay, so therefore we said that Arrhenius definition was based on the concept if any substance at all is able to produce hydrogen ion, it is termed acid. If it's able to produce hydroxide ion, it is termed base. But when it comes to Bronsted Lowry, they are basing their definition on proton transfer reaction. So they are also saying that a substance becomes an acid if it is able to what? Donate a proton, and a substance becomes a base if it's able to accept a proton. So let's look at Lewis' definition of acid and bases. So Lewis. Now Lewis also realized that there are some substances that exhibit acidic and basic characteristics but do not fall in either Arrhenius definition and Bronsted Lowry definition. So he realized that there are substances that accept an electron pair, and there are substances that donate an electron pair, and these substances behaves as acid and bases. Okay, they have the acidic and basic characteristics. So he also came and said that acid is an electron pair acceptor. So his definition was based on electron pair. So electron pair. Okay, so his definition was based on electron pair. Okay, so he said that an acid is an electron pair acceptor. So acid would accept, so electron pair acceptor. So electron pair acceptor. So that is his definition of acid, Lewis. So Lewis' definition of acid and base was based on electron pairs. So when a substance is able to accept an electron pair, it is termed Lewis acid. So therefore the base is, or a base is an electron pair donor. Okay, so look at the definitions very well. We started with Arrhenius definition, and we said that one is based on whether a substance will be able to produce hydrogen ion or hydroxide ion. So if it's produce hydrogen ion in water, it is termed acid. When it's produce hydroxide ion in water, it is termed base. Then Bronsted and Lorry realized that there are some substances that exhibit acidic and basic characteristics but do not produce hydrogen ion or hydrosomium ion in water. Okay, so they base their definition on whether or not a substance is able to donate proton or accept proton. So if a substance is able to what? Donate proton, then it is termed what? Bronsted-Lowry acid. If it's able to accept a proton, then it is termed what? Bronsted-Lowry base. Then Lewis also realized that there are some substances that has acidic and basic characteristics but are not present in Arrhenius definition and Bronsted-Lowry's definition of acid. So he based his definition of acid and bases on the concept of electron pair. Once a substance is able to accept an electron pair, then that substance is termed an acid. Once a substance is able to donate an electron pair, it is termed what? A Lewis base. So we will try to use this understanding to be able to fish out some of the substances when they are being mixed up as to whether they are Lewis acid, they are Bronsted-Lowry acid or bases, they are Arrhenius acid or bases. Okay, so understanding the various definitions is very, very key. Once we understand the fundamental, then the build-up will be very easy. So this is where our time would permit us today, and I would like you all to hit the subscription button if you have not, and also the notification button, so that in our next lesson we'll be looking at how we can apply the various definitions we've gotten to be able to fish out some examples that are under Arrhenius, those that are under Bronsted-Lowry, and those that are under Lewis. Okay, and we have two terms. We have some two terms that confuses a lot. We have amphiprotic and amphoteric. Okay, so in our next tutorial we'll be looking at how to get a clear difference between this amphiprotic and this amphoteric. Okay, so stay tuned, okay, for more educative and interacting lesson sections. Okay, bye.